Hello, welcome to the fifth part. Today we will do three things. We'll start by fixing a minor issue that was implemented last week in the builder mode. Then we will add shadows and fix the lighting. It won't be the final render, but it will be more pleasant to work with this. And finally, the main theme of this video, it will be to add a shop. Please have a look at what we will build together today. Let's start by getting the fourth part to build the next one, the one we will do today. Go to my repository, part 4, go to code and copy the clone URL. First git clone the repository, I did it into part 5. Go to server, run yarn and yarn dev to start the development server. Open a new terminal, go to client and run yarn. Then when it's done, yarn dev to start the development server. When you click on the URL, you should see this. This is the project we did so far. So we have our character in a room. We can click here to open the builder mode. So we can move, click on items and move them. Let's have a look at the issue I found. So if we take this mirror here and we try to move it here, it works. But if we rotate it, it should be able to go there, but it doesn't work. So let's look at why it's happening. This is happening in our experience. And the thing that decides if we can or cannot drop something is can drop. And where is can drop defined? It's where we do set can drop. And this is triggered in a use effect. But let's have a look at what change our use effect is the drag position, the dragged item and the items. But we require one more thing, which is the drag rotation, drag item rotation. Now, by adding it to the list of the effect, use effect will be triggered, and the logic, which was correct, will be triggered. But we also need to change something because before we didn't have the dragged item rotation. So to make it taken into account, here we don't have to look at the item rotation, but we have to look at the dragged item rotation, because now it can change while we are drag and dropping it. Here and here. We can save it. Now let's switch to build mode. Let's take the mirror. Here it's working correctly. And now if we go, we can put it here. Perfect. Before jumping to the shop mode, let's do some polish. First of all, when we are in this mode, we don't need the grid. We only want it when we are in build mode and maybe in the shop. Go to experience, check where is the grid defined. Let's do some conditional rendering around it. Build mode and the grid. Let's also get the shop mode. So build mode. Let's get the shop mode. Shop mode atom, and we check that we are not in shop mode. It is because when we are in shop mode, we are also in build mode. Maybe we could have made it differently, but it's the case right now. I'd also like to state that we are building this project first horizontally, which means we are not spending too much time on the details and on the beauty of the code, so we could refactor it later. Everything is not perfect yet. We will try to enhance it little by little. But if I want to keep the rhythm of one video per week, and if I want to provide you with nice features and not just bug fix and code cleaning videos, we have to skip some details for now. Okay, so now we don't have the grid when we are playing, and when we open the build mode, we have our grid. Let's add shadows. I think we already have shadows enabled on the canvas, so this is good, but if you don't have it, please add it. Now let's go to experience, find the light, which is here. Let's add a directional light. We will position it with -4, 4, and -4. and we will enable cast shadow on it. And for the intensity, we will set it to 0.35, so it's not too intense. For now, we can't see it because we don't have items that are casting shadows, nor items that receive shadows. First, let's set the plane, so the floor, to receive shadows. So on the mesh, which is here, we can say receive shadow. Then we can go on the character, animated woman, find the mesh, so here skin mesh, and add cast shadow. We don't need to receive shadow on the character, but add it on all the meshes. If there are too many, we could also do it by code, by looping through all the items. Okay, now we can see the shadow here, but it isn't on the objects, and it isn't if we go too far because of the shadow size. First, let's add shadow on all items. To do so, we go to item, and then we don't have like all the meshes available here. So what we need to do is to do it programmatically. To do this, we will be using a use effect. So it's triggered only the first time when our component is instantiated. Then we will do clone. So it's our mesh that we cloned. Traverse, we will have access to all the child. So for each, we will have a function called. We will check if our child is a mesh. Then, if it's the case, we will cast shadow and we will receive shadow. Now we can see the nice shadows. If we go in front of the bathtub, you can see the shadow of the character on the bathtub. But the light is a bit too bright. Let's decrease a bit the ambient light. Go to experience, find the ambient light, reduce the intensity. Because we have the ambient light, we have that directional light, and don't forget that we have the environment that add nice lighting effects. This is what we have. It's still way better than what we had before. If we go into the building mode, we move items, we have real-time shadows. But you can see there is here an issue that the shadow is broken. If we go to this part, shadows are not working anymore. To understand why our shadows are stopping, we need to go to three.js documentation to understand directional light. We can see this line, this light can cast shadows. See the directional light shadow page for details. So let's open it. What can we learn from it is, unlike the other shadow classes, this uses an orthographic camera to calculate the shadows rather than a perspective camera. What it means is that under the hood, a camera is used to calculate the shadows. So we need to set up that camera correctly to calculate it everywhere where we need. By chance, if we look at React 3 Fiber documentation, they have an example on how to use directional light and to use a nested orthographic camera that we will attach at the shadow camera for our directional light. So we have control here with the arcs on what we will be using for the left, top, bottom, and right values of our camera for the directional light. Okay, so let's just make it quick. We won't make it generic with every map size. We will just make it work for this specific scenario. The first thing we need is the shadow map size. So it will be the quality we want for the rendering of the shadows. We will be using the same than in the example. Then in our directional light, we will add an orthographic camera. We need to use attach and say it will be the shadow camera. I forgot the double quote here. Okay, now let's use some arcs. So for example, we can use the map size, but it's not perfectly accurate because based on the position of the camera, the rotation and stuff, it won't be perfect. But still, we will use it for now. So here I will hard write 10 and minus 10, but if you have a big map, it won't work. Okay. And we also need to define the far property. We will be using map.size and we will add the map.size of 1. I try to make it generic, but it's not the case. It would need a more complex calculation. At least with those settings, it works for this case. You can see the shadows are working on all items. Perfect. Now let's jump to the shop mode. So far what we have is when we open the shop, nothing happened, just the grid disappear. For the shop, let's hide the room and move the camera. Okay, so we already have a condition with the shop mode, so we have it available here. Currently, we were checking that we are in build mode to know what items we want to display, But now we want, first of all, to check that we are not in shop mode. So now we don't have items anymore. And if we go back to the build mode or the experience, they are here. We can do the same for the plane because we don't need it. Where is it? Here we have the mesh of the plane. We can wrap this mesh in. We are not in shop mode. Now if we go to shop mode, we have nothing. We can create our 3D shop here. Let's create that shop. Go here, components, new file, shop.jsx, export const shop, and we'll return a group for now. We can close it. On the left, in the experience, we will check maybe before, if we are in shop mode, then we can render our shop. Now in the shop, what we will want to do is to list all the items on the x-axis. First thing we need is the items. We get them from useAtom and items_atom. If we have correctly from the socket manager, did we create it? No, we need to create it. So we have items_atom. We need to make it available here. So items and set items. It will be using items_atom. And it's on hello. We have the items. Let's check in the server if it's correct. Go to index of server, hello, and we were giving the items. So we should have them available in the onHello callback. We set them into our state. Okay. Now in our shop, we should be able to use items_atom, and we have the list of items here. Because we want to display them on the x-axis, we will need a variable to compute and increment the x position based on the item size. So to make it easy, we will do it inside a use memo so we don't compute it every time. And we only compute it if the items list change. This use memo, it will return the shop items, and we will render those shop items here inside our group. So let's say we have let x is equal to 0. So we start from the 0 position. Then we will return, let's do it with boxes for now. So mesh, box geometry, and mesh standard material with a pink color. Let's increment the x by 1.5 because it will be 1 for the box geometry and 0.5 for the space between boxes, and assign this size, this x position here. But we don't want them to have the same. So it will be const x position will be equal to x, and then we increment that value for the next one. So here it will be x pose. Okay, if we open the shop, we have only one. It's because I didn't iterate through all the items. We need here to do return object.values, so through all our items, and we will map through all those items. So here and here. We can also get the index from the map and assign it as a key to this item. And I also made a mistake with the position. It's position X that we want to set. Now, if we look here, we have all our items, which are rendered with box from now, but we will render the real items. Before adding the real items, let's add some scroll effect so we can see all our items. Go to the application, and let's wrap our experience into scroll controls. And let's say, for example, 4 pages. So we just have some space to scroll through. It's not important, the value. It will just make the scroll bar bigger. Now we can see the scroll bar, but if we scroll, we have the orbit controls that is catching the events. To get rid of that, we can just disable it. So we'll go to orbit controls. We disable it. So we set enabled to false if we are in shop mode. So if we are not, well, if we are in shop mode, it's disabled. Now we can scroll and it moves. We need our shop to react to this. So we need a reference to our group. let's name it shop container. We will move it accordingly to the scroll. We will also need to know from where we scroll, so from 0, but the maximum where we can scroll when we have all our items shown. So we will store a reference, max x. We'll set it to 0 by 0, by default, sorry. We will use a reference to store it. And after increasing the x, we'll say max x is equal to x. Well, it's maxx.current. Now we have the data we need. We can set up our system to scroll our container. So the container, we store it in a useRef. And in a use frame, we will implement our logic. We will need the scroll information. We get it in scroll data object with useScroll from Drei library. Now we simply do shop container dot current dot position of x. It will be equal to minus scroll data dot offset. So a value between 0 when we didn't scroll to 1 when we scrolled entirely. So it's a percentage. We multiply it by the maximum of x position we know. Now we can scroll and it slide our items from the first one to the last one. It's an implementation I chose for the shop, but of course you can do whatever you like. Maybe you don't want to use scroll, you want to do some categories. I wanted to make it simple and 3D thought. Just before adjusting the camera position so it looks good, what we want to do is to render the items instead of this box. Let's create a shop item component. We can create in another file, but as it's really related only to the shop, I will create it here. Const shop item. Nothing will use it outside of this. So it will need the props of the item to know what we need to display and the other props, for example, to control the group position. We need to render our 3D item. We already did in the item component, so we can copy the same logic. So we have the map, the scene, the clone. We copy this. We go to our shop item. We import everything that is required. Map atom, use GLTF. The name, we will get it just after. Use memo, we already used it. Skeleton utils. Okay, we need the name, so we will destructurate it. Also the size from item. We will also need grid to vector 3 to convert the position and place our item correctly. Now we can render it. So we will return a group so we can easily position it. We pass the rest of the props. And inside we will have a group with the position set to grid to vector 3. And this is used to center the item. So we will just act as if it was at a 0, 0 position, but we will pass the size of the item. So it's size of 0 and size of 1. So the width and the height. So it just center it correctly. And now we'll use, as we did, primitive object and clone. Well, we also have map that is unused. We don't need it here. And instead here of rendering that mesh, we will render a shop item. It won't need anything here, but we need to pass the prop item. So it has all the information it requires to render that object. Now what happens if we look at the shop, we can scroll, and it was nice at the beginning, but when items are bigger, they are fighting with each other. This is easy to fix. It's because we incremented it by 1.5, which was arbitrary. But now we have the item size, so we need to increment it. So item.size of 0, because we are only affecting the x-axis. But we also need to divide it by the map.grid division. Then we can add an offset, which is the space between items. Let's say we will add 1. Do we have map? No, we don't have it. So we need here map is equal to use atom of map item from Socket Manager. Now we can scroll. We have all our items spaced evenly. Let's change our camera position. Go to Experience. We have a use effect with the build mode. We'll do almost the same, but with the shop mode. Okay, so now it will be if we open the shop mode, else we are closing the shop mode. So if we are back in build mode, it will be this. But if we enter in shop mode, first we don't want to touch the items. It's not this logic. And we have to choose a camera position. I think in front of the item, a bit above, so we have some perspective. And 8 should be fine. It looks we have an issue with the camera controls. Oh, it's because I completely disabled it. But what we want to do is just to disable the zoom. Let's try again. Okay, now our controls are working. So we can scroll, we can go back, we can reopen it. And because it kept the scroll, we are where we stopped shopping. Okay, perfect. Let's add an event to pick items when we click on it. Into the shop, let's add on item selected prop. Then simply on the shop item, on click. It will work by default because we are passing the props to this group here. So we have access to on click, on item selected, and we will be using the item we already have. We can save. Now in experience, our shop, we have on item selected. We create our on item selected too. Let's go to the code logic here. On item selected, we have an item. What we will do is we stop the shop mode. We set it to false. Then we will set our items. We get all the previous ones. So we will return all the previous one. Then we will add all the info from the item we selected. But we will add a grid position of 0, 0. By default, we just want to set it at the beginning position. And we will add a new info, TMP, so temporary, and we set it to true. We can close here and save. Now we have the item in the items that we are temporarily editing. We need to set the dragged item. It will be items.length. Why not length -1? It's because the set items doesn't have time to be triggered before we set drag item. So it's the previous length. We also want to set the rotation to 0. Let's try it. We go to the shopping mode. We select an item like this bed and we have a crash. If we look why, it's because we don't have a drag position. To avoid this issue, let's find a drag position, the definition, and we will set it by default to 0, 0. Let's try again. We select an item, this bed. We can move it. We have our item selected. We can drop it. Okay, but what happens if I select something else and I just cancel? You see it's stuck here. It's because we need to remove the temporary items we created. To do so, we can just have a new use effect that we will trigger when dragged item change. So if dragged item is now null, we will set items to what we have, but we just filter the temporary items. Let's try again. We open it. We select any item, this table. We fake the movement. We cancel. And now it's not available here. We can select it, but it also was removed. Okay, it's because we need to remove the TMP if it's something we really want to put. Where is that logic? It's in can drop. If can drop, okay, here we set the new item. So to set the new item, we also need to delete new items of dragged item of TMP. So it's not temporary because, okay, we drop it at a position we can drop it. Let's try again. Go here, we go to the store, an item we don't have yet. what do we have? We have a nice shop where we can spend time on it. Maybe we want this beautiful computer. Where do we want to put it? In our bedroom. We want just next to our bed. It's always good to code. And now it's working. Now our character can play computer. Thank you for watching, I hope you enjoyed this video. If it's the case, as always, please hit the like button, subscribe and share it with your friends. It really helps the channel grow. Let me know in the comments what you'd like to see in the next video. I'm thinking about the next one to be the character builder. I will be using Ready Player Me SDK to integrate avatar customization without having to design anything. We are getting closer and closer to the end of this video series. Of course, it's educational content, it's not a project you can just take and put in production, but I think you have a lot to learn from it, and I will do other video game tutorials. If you still want to learn, you can watch the previous part or watch my other video tutorials available here.